Logarithmic functions. Exponential and logarithmic functions are inverse functions. Recall that inverse functions are functions that are formed by switching the x and y values in their equations. Their graphs are found by reflecting the other across the line y equals x. The graphs shown to the right are y equals e to the x and y equals the natural log of x. The asymptote in the parent exponential function is y equals 0, or the x-axis. Since exponential and logarithmic functions are inverses, the asymptote in the parent logarithmic function is x equals 0, or the y-axis. Similarly, instead of always having a y-intercept as exponential functions do, logarithmic functions always have an x-intercept. As with other inverse functions, the domain and range of exponential and logarithmic functions will switch. Y equals e to the x has a domain of all real numbers and a range from 0 up to positive infinity. Y equals the natural log of x has a domain from 0 up to positive infinity and a range of all real numbers. Graph the function y equals log base 3 of x. To graph the function, select x values that are powers of 3 to make finding their logarithms easier. So here we have our x values. Once we plug them into our equation, we get our y values. So when x equals 9, y is 2. When x is 3, y is 1. When x is 1, y is 0. When x is 1/3, y is negative 1. And when x is 1/9, y is negative 2. So it's going to look something like this. Here is a much nicer looking graph. Consider the incomplete table below. The entries in the table were produced by the logarithmic function h of x equals 3 times log of x. Fill in the missing entries in the table. Let's take one of these as an example. When x equals 1, we have 3 times log of 1. Now remember, this is log base 10. So what is log base 10 of 1? 10 to what power gives us 1? That is 0. So this whole thing here is 0. 3 times 0 is 0. So if you just plug in all these x values here, you can get the y values as shown. Transformations also occur in logarithmic functions. The relationship between the general transformations formula and exponential functions with transformations is shown below. Y equals a times f of x minus c plus d. Over here we have y equals a times log base b of x minus c plus d. When performing transformations on logarithmic functions, the domain, range, x-intercept, and asymptote will change. Here's an example. Let f of x equal log base 2 of x, shown here in red. Graph g of x equals 3 over 2 times f of x. Then describe the transformations that map the graph of f of x to g of x. Alright, well the quickest way to do that is to pick these 2 points here. And instead of having a y value of 1, our new function is going to take that value of 1 and multiply it by 3 over 2, which gives us 3 over 2. So the point over here will be at an x value of 2, but a y value of 3 over 2. This point is at x value of 4 and the y value of 2. So we take that 2 and then multiply it by 3 over 2 and we get 3. So the new point will be there. Alright, and so when x equals 1, it's 0, and 0 times 3 over 2 is 0. So this point remains right where it is. But now the graph looks something like that. We've had a vertical stretch away from the x-axis. Vertical stretch with a factor of 3 over 2. Analyze the function. Alright, so here we have our function. The domain is from 0 to positive infinity, not including 0 since that is our vertical asymptote right there. The range is all real numbers, so from negative infinity to positive infinity. The x-intercept is right there at 1, 0. And it's increasing, since from left to right, it's going uphill. And there you go. Here's an example. Let f of x equal log base 2 of x. Graph g of x equals negative f of x plus 2. Then describe the transformations that map the graph of f of x to g of x. Let's begin by figuring out where g of 2 is. So g of 2 will be at negative f of 2 plus 2, which is 4. What is f of 4? Well, we can just look at the graph. That's 2. So negative f of 4 is negative 2. So we have a point right there. Let's graph out g of 0. When x equals 0, we have negative f of 0 plus 2, which is 2. F of 2 is 1. Therefore, negative f of 2 is negative 1. So when x equals 0, we have a point right there. We're going to have an asymptote right there at negative 2, and our graph is going to look something like this. A reflection across the x-axis and a horizontal shift to the left 2 units. And there you have it. Analyze the function. Here the domain is from negative 2 to positive infinity, not including negative 2 since that is the vertical asymptote. The range is all real numbers, so from negative infinity to positive infinity, the x-intercept is right here at negative 1, 0, and from left to right it is downhill, so it is decreasing. And there you go. Here's another example. Let f of x equal log base 2 of x. Graph g of x equals 2 times f of negative x minus 4. Then describe the transformations that map the graph of f of x to g of x. All right, so here we have f of negative x, which is a reflection across the y-axis. So let's check out g of, say, negative 1. That will equal 2 times f of 1, since negative, negative, two negatives, minus 4. So what is f of 1? Let's go over here and look. At 1, it equals 0. So this becomes 0, and our answer is negative 4. So at negative 1, we have a value of negative 4. What about when x is negative 2? So at negative 2, we will have 2 times f of negative negative 2, which is positive 2, minus 4. F of 2, let's look over here, and that is 1. So we have 2 times 1, which is 2, minus 4 gives us negative 2. So at negative 2, negative 2. All right, what about when x is negative 3? So we have 2 times f of 3, since the negative signs cancel out, minus 4. What is f of 3? Well, 3, it's somewhere around 1.5. We'll say it's about 1.5. So 1.5 times 2 is 3, minus 4 is negative 1. So it's close to negative 1. We'll just put a dot there. All right, what about at g of negative 4? So that would be 2 times f of 4 minus 4. F of 4 is 2. So 2 times 2 is 4, minus 4 is 0. So here is our x-intercept, right there. All right, now what about, let's choose negative 6. So g of negative 6 equals 2 times f of 6 minus 4. So what is f of 6? It's about 2.5. 2.5 times 2 is 5, minus 4 is 1. All right, so that's like right over there. Okay, so we have a graph that is looking something like this right there. Here is a much nicer looking drawing of the graph. It has a vertical stretch with a factor of 2, a reflection about the y-axis, and a vertical shift down 4 units. Analyze the function. The domain is going to be from negative infinity up into 0, but not including 0. The range is all real numbers. The x-intercept is right here at negative 4, 0. The vertical asymptote is the y-axis at x equals 0, and from left to right it's going downhill, so it is decreasing. And there you go.